Welcome back, guys. This is lesson 2 in unit 2. We're talking about conditional statements. Now, a conditional statement is just an if-then statement. So there's conditions on what's happening. If this happens first, then this can happen. Now, here's an example. If you eat fast food, then you are unhealthy. It doesn't have to be true necessarily. We'll get to that later. But there's two parts to a conditional statement. The if part, the then part. So in this specific example, if you eat fast food, then you are unhealthy. So I'm going to box in what follows the if and what follows the then, because those two statements there have a name. So what follows if, that's called the hypothesis. And we'll put in parentheses here, that follows the word if. What follows the word then, that's called the conclusion. Now, if this happens, we're stating here's the hypothesis, then this will happen, the conclusion. Again, whether it's true or not, we'll get to that. You're going to see these if-then statements being symbolized. So I have no idea where, honestly, these letters came from, but somebody out there chose to give the hypothesis a letter and give the conclusion a letter. No idea why it's these letters, but the hypothesis, you're going to see them call that P. I guess H would have made too much sense. I don't know. And then conclusion, again, C would have just made too much sense, so we decided to use Q. So hypothesis, we're going to call it P. The conclusion is always going to be called Q. And I'll show you where this comes in later. They're going to symbolize this, like I said. So let me put that down here at the bottom here. They're going to symbolize this, P. So if the hypothesis happens, and then they're going to arrow it over to the conclusion, or Q. So you're going to see like P to Q. If this happens, then this happens. Now, I want you to note something, and it seems like a really small thing, but it's mentioned a lot and it's confused a lot. When you state what the hypothesis is for a conditional statement, you don't include the word if. So I would just say, you eat fast food. That's the hypothesis here. And when I state the conclusion, I'm just following what's after then. Okay, I'm not saying the word then. So I would just say, you are unhealthy. That's the conclusion. Okay, so leave the if and the then out when you state the hypothesis and a conclusion. Okay, now, conditionals, and I kind of mentioned this, they have a truth value. Just because you eat fast food does not mean you are unhealthy necessarily. A lot of factors there. So we're going to have a truth value, either true or false. Now, to show that a conditional is false, we kind of talked about this last lesson when we did inductive reasoning, but it's way easier to prove something is false than true. To show that something's false, all you have to do is provide one counterexample. Give me an example where that statement actually is not true, and I believe you, it's false. So that same kind of stuff is going to come into play. And guys, I know this stuff kind of seems like, wait, this isn't math, this isn't geometry, but Unit 2 is all about reasoning and proving stuff, because we need these tools here to do what's coming ahead of us in Unit 3 and Unit 4 specifically. So we're just kind of laying the foundation for a lot of this basic stuff that will help us do more complicated stuff later. So here's an example. State the truth value, true or false. And if it's false, provide a counterexample. Notice that this is a conditional statement. If this, then this. So the hypothesis is a squared equals 25. The conclusion, a has to equal 5. So is this true? If a squared equals 25, then a has to be 5. A lot of us would say true, but this is actually false. Not very nice to give you this all on your own. And I don't know if you can think of the counterexample, but there is one other number that I could plug in for a, and when I square it, I get 25. And that number is not positive 5. It can also be negative 5. -5 times -5 is positive 25. So I just proved that this conditional statement is not true because A equals -5. That works as well. That's my counterexample. Okay, now here's where we really get into stuff where you're like, wait, this is not geometry. But again, it's all about just setting the foundation. There's actually 4 ways to write a conditional statement. If this, then that. They have names. They're kind of random. And we're going to write all 4 of them in this little chart set up down here below. You'll see this a lot. So here are the names. There's a regular old conditional statement, and then there's 3 others that follow it. So let's start basic, and we do want to say the truth value of every statement, true or false. If it's false, we have to say what a counterexample is. So here we go. So here's a conditional statement. If you live in Fort Wayne, then you live in Indiana. Let's identify the 2 parts because that's going to be part of what you're asked to do here. So if they said, hey, what's the hypothesis? I would say you live in Fort Wayne. What comes after if? And remember, we call that P. The conclusion is you live in Indiana. Remember, we call that Q. So to symbolize this, we say P to Q. If this, then this. Already talked about all of that. So let's analyze now if this is a true statement. If you live in Fort Wayne, then you live in Indiana. That's true. Fort Wayne is in Indiana. So definitely got to be true there. Okay, so there's basically what I'm asked to do this lesson, guys. To be honest, that's it. But there's 3 other ways to kind of write this information. We're going to be flipping stuff, putting the word not in. This is all kind of weird, I know. There's something called the converse of a conditional statement. So the converse is you just take this original statement and you flip the hypothesis and the conclusion. So I'm going to write that off to the side here. You should too. But I'm just going to flip this around. And that's me writing the converse. In other words, I'm going to flip P and Q. So Q is going to come first, then P. Here's where the symbols maybe will come in handy. Otherwise, you don't need them. So here's what I do. I do not flip the words if and then. A conditional statement is always if this, then that. So it's still if blah, 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 then blah, blah, blah. I'm just going to take the conclusion. You live in Indiana. And I'm going to write that after the word if. And then I'm going to take the you live in Fort Wayne, the hypothesis, and I'm going to write that after the word then. Now I have to say whether this is true. So if you live in Indiana, then you live in Fort Wayne. This is not true. This is false. And I'm going to give a counterexample. So, okay, think about it. Just because you live in Indiana doesn't mean you live in Fort Wayne. There's a million other places you could live. Not a million, but you know what I'm saying. Counterexample, I'm going to pick my favorite other place in Indiana. You could live in Bloomington. You could live in Indianapolis. You could live in Muncie, South Bend. There are tons of other cities you could live in besides Fort Wayne, and you still live in Indiana. Okay, so that's a converse. You just flip it around. The inverse, you don't flip it. You do what's called you make the statement negative. So you make it negative. You keep the order the same, and we kind of we always go back to the conditional statement when we write these other ones. So ignore the converse. That's not related to the inverse. Come back to your original conditional. You leave the order the same, so don't flip the statement around. We're just going to insert the word like not and make these negative little phrases here. So here's how we symbolize it. It's still P, then Q. We just add this little squiggly, and that means not. So it's not P, not Q. So I'm just going to say like not, use correct English, say don't if that makes more sense. Watch what I'm going to do here. So I'm going to say if you don't live in Fort Wayne. I'm just making that statement negative. Don't flip it. So if you don't live in Fort Wayne, then you don't live in Indiana. Okay, truth value. I don't know about you guys, and this is going to happen every example. It is a lot more challenging for me to decipher whether that's true or false the second you start throwing negatives like don't and not in there. So let me teach you a trick. If you can say what the truth value is of the first two, you automatically know the last two. So do not even like waste your brain power trying to decide if that's true or not. Okay? The first statement and the last statement. So that's going to be the conditional and what's called the contrapositive. Those truth values always match. So if I know that the conditional is true, the contrapositive is automatically true. The middle two also always match. So if that one's false, this one has to be false. That's way nicer for me than trying to decipher, if you don't live in Indiana, then, or don't live in Fort Wayne, you don't live in Indiana, just copy off of yourself. And use the same counterexample. It's going to work there too. Way easier. Okay, the contrapositive, basically you change everything about the conditional statement. You flip it and you make it negative. So you do these two things. So the symbol, it's going to be Q first, then P, and it's going to be the nots. So basically it's going to be if you do not live in Indiana, or don't live in Indiana, then you don't live in Fort Wayne. Again, come back to the original conditional statement when you write all these. Okay, on the back real quick. So there's one more example. I'll kind of get you started, but then I'll have you fill it in yourself. So the conditional statement here is if a figure has four sides, then it's a square. Yay, let's get into some math. Okay, P, figure has four sides. Q, it is a square. Is that true? If it has four sides, then it's a square. That's false. There's a lot of figures that have four sides that are not squares. Rhombus, that's a counterexample. A trapezoid, lots of examples here. So any of those would work to prove that just because it has four sides doesn't mean it's necessarily a square. Now, I'm going to write the converse. I'm going to have you fill in the bottom two and tell me the truth values off to the sides as well. Remember the converse, and you have to flip back to the front. That's cool. But the converse just flips it. So Q comes first, then P. So I'm going to say if a figure is a square. You could say if it is a square, then a figure has four sides. As long as I can tell you know to flip it, I'm not super picky about the English here. If a figure is a square, then it has four sides. And let's see, is that true? If a figure is a square, it has four sides. Yes, squares have four sides, so that's true. Okay, I'm going to write the little symbols in here for you. And then I'm going to have you guys finish off these notes and fill in these last little boxes here.